Hi, Blue Teamers. I hope you are all doing well. We're back to making videos again and starting our new unit on Earth history. And the first thing we're going to be talking about are fossils. And if you were in the class right now, I would be asking you, well, what is your definition of a fossil? And the answers I usually get are things like, a dinosaur bone, a shell and rock, and so on. And those are possibly examples of fossils. But the real definition of a fossil is any evidence of past life that is at least 10,000 years old. So you should right now have uh, opened up that Google slide that I sent you. And the first thing you need to fill in under the definition of a fossil is, as I just said, any evidence of past life that is at least, and you should fill in, 10,000 years old. So, Rosie, if you'll show them, you should have filled in 10,000 years. So, something like a leaf. Oh, don't push that there, Rosie. That's not a fossil. It's evidence of life, but it's definitely not old enough. Okay? So, something like what Rosie's holding there with the shapes of those brachiopods, those are hundreds of millions of years old. So they have to be at least 10,000 years old and show evidence. So could it be something like a shape of a shell like you see there? Could it be something like a fern impression? Yep. Could it be something like a skull, a footprint, a pine cone, a nest, dinosaur bone, or petrified wood? Well, some of what I've just mentioned are fossils, but some are not. The nest, if it was a dinosaur nest, yes, it would be a fossil. But this is just a bird's nest that really isn't all that old, so it is not truly a fossil. Now, several thousand years from now, if that would somehow be preserved, yes, it would be a fossil. This footprint, well, that was made by a human being. So that's not really a fossil. But could there be a real footprint that's a fossil? Yeah, that's evidence of life. Same with a pine cone. This is not a real fossil. And it's a pretty big pine cone. And let me just show you what I mean by that. Rosie, hold that. That is a really large pine cone. But it's not 10,000 years old. The dinosaur bone, which we'll talk about a little later, the petrified wood, real fossils. This skull, if it was 10,000 years old, it's evidence of life. And we'll talk about other types of evidence besides things like nests, okay, and the things I just showed you, footprints. There are other examples that show evidence, but aren't really, but are truly fossils, even though they don't really show the part of an organism, they just show evidence. Now, if we had a piece of coal or a piece of limestone, we know they came from living things, but do they really show any evidence of that life? No. So even though they are millions of years old and we know they came from living organisms, they aren't really fossils. So what we're going to start doing next is talk about, what leads to fossils forming. And it's not an easy process, and the different types of fossils. Okay? So we'll move on to that. Okay, so we've now defined a fossil as any evidence, and evidence is a really important word. Evidence of past life that is at least, and you should have filled this in on your Google slide, at least 10,000 years old. So we are going to start talking about the different types of fossils when Rosie has some of those in front of her right now. But before we do that, I just want to kind of point out to you that why are we learning this? What's the point to learning about fossils? Well, yeah, fossils obviously tell us a lot about the different organisms that have lived on our planet in the past. But besides that, fossils also give us clues to the changes that the Earth has gone through in the past. For example, if you find fossils near your house of shells or fish, Things that obviously lived in an ocean, not just a creek or something, but are evidence of ocean life. That tells you in the past that there was once probably a shallow sea in your backyard. And we talked about that with rocks, how coal tells us there was once a carboniferous forest, something we'll be talking a little bit more about later, or limestone, another clue to there being a shallow sea, or the presence of salts like halite and things like that. So, we're going to be talking about the Earth's history, and these fossils are what gives us big clues to the changes. They have found plant fossils on Antarctica, and obviously Antarctica right now, there aren't any plants growing there. So that tells us things have changed. And, millions and millions and millions of years is a lot of time for changes to occur. We're going to be talking about millions and millions of years. So to become a fossil, so as we start talking about our different fossil types, it is not an easy process. I mean, all the organisms that have lived on this planet, very few ever become a fossil. And if you think about that, there's a lot that can happen to something. That leaf that we showed you earlier, and I still actually have it. So that leaf that Rosie's pointing to, that's going to decompose. And what's going to decompose it? Or sometimes we use the word decay, bacteria. We can't see them, but they're going to break those down. All the leaves that fall off the trees in the forests and so on, those are going to be broken down mainly by bacteria. Even, the poor old raccoon that lived a good life and now has moved on to the next level, his body parts are going to decompose or get eaten by scavengers or something like that. But those invisible bacteria, they're bigger than viruses, but they're still extremely small, are the main decomposers of our world. So to become a fossil, we need to prevent that. And one thing that has to happen, pretty much, is it must be covered or buried quickly. Mainly in sediments, which are, things like sand or dirt or mud or silt. And you find a lot of that in a water environment. They're going to cover up these organisms that can possibly become fossils. And that will slow down at least, and slow down a lot, that process of decomposition of the bacteria breaking it down. So on your Google slide under number 1, where few organisms become fossils, you see letter A quick, and what would that be? What did I just say? Rosie, do you know? Can you raise your hand, Rosie? Give me paw. Can you give me your paw? Sit up. What's the answer? Where's your paw? Give me paw. Oh, there you go. Good. It is the word burial. So on your Google slide, for number 1, a quick burial in sediments is pretty much a necessity. So write in the word burial, B-U-R-I-A-L. And on the Google slide, you see the other part, being, no pun intended, a hard part. Things like bones, shells, teeth, help in something becoming a fossil. Not necessarily a necessity, but they are very, very helpful. And the reason is, think about things like shells, bones, teeth, pieces of wood. Those are hard parts. And they're going to decompose a lot slower. If you think about the raccoon again, all the fur and the fleshy parts are going to decompose first. The last things you see are the bones and the teeth, because they decompose much slower. They will decompose, but at a much slower rate. And if they get buried and the bacteria can't get to them, there's a chance they can become a fossil. So being a hard part is very, very helpful. And the thing that is definitely a necessity is a quick burial.